So today we are looking at writing chemical formula. Every subject has its own special language, as you might have realized by now. For example, in chemistry, you have substances with names like sodium chloride. However, you have a short form of writing names called formula. So, in writing chemical formula, we have a way where we'll be writing this chemical, in which we'll be writing this chemical formula. We'll not be writing the words themselves, but we will use formulas to write them. Now, as we have said that in every subject has its own language, every subject has its own special language, as you might have realized by now. For example, in chemistry, we have substances with names like sodium chloride. However, we have a short notation of writing names called formula. Now, the short notation that we are using to write those words, we are calling it formula. The formula for the compound, the formula of a compound shows the formula for a compound. The formula for a compound shows the atoms present in the compound in their simplest ratio. Now, the formula of sodium chloride, we realize that it is NaCl. The formula for water will be H2O. Now, we have to ask yourself, why then do we write the number 2 in the formula for water, whereas we do not in sodium chloride? These are some of the questions that we shall answer in this section as we discuss how to write chemical formula. We have questions that we'll ask ourselves, where we'll answer them as we continue. We are saying that the formula of a compound shows the atoms present in the compound in their simplest ratio. The formula of sodium chloride, as we are saying, that is NaCl, where A and L are small letters. The formula for water is H2O. So we are asking ourselves, why then do we write the number 2 in the formula for water, whereas we do not in sodium chloride? So we are saying that these are some of the questions that we shall answer in this section as we discuss how to write chemical formula. Those are some of the questions that we are going to answer. Always remember to write a correct formula. To write a correct formula, we must write down the. Now, when we want to write a correct formula, we have some points that we have to consider. So, to remember to write a correct formula, we must write down the following. 1. Correct symbol of the element or the radical. So, what will take place in a chemical reaction, it will be either the element or the radical. Remember, when we began the topic, we say that with the topic structure of the atom and periodic table, we say that atom is the smallest particle of an element. Now, what is taking place? What is reacting? The element. Now, the particle that is reacting is the atom. Now, atom is the smallest particle of an element. Now, the element is what we are indicating as what is reacting, but the exact thing that is reacting is the atom. Now, To write a correct formula, we must write down the following. You must write down. To write the correct formula, we must write down the following. So 1, correct symbol of the element or radical. Correct symbol of the element or radical. That's why when we began this, we first looked at the symbol of the elements. Where I began the symbol of the elements in Form 1. The symbol of the elements in Form 1. Then 2, correct valence of the element or radical. Correct valence of the element or radical. That's why in the first case, when we were discussing about the ionization energy, the electron affinity, oxidation number, we also discussed about the valency. Now the correct valency of the element or the radical. That's what has to be at your fingertips when you are writing any chemical formula. Let us write the formula for sodium sulfate. Let's try and write the formula for sodium sulfate following the steps below. You have a number of steps that you want to follow so that you can be able to write chemical formula, the correct chemical formula. So let us write the formula for sodium sulfate following the steps below. Now let's look at step 1. We are saying that write the symbol of the element and the radical. The elements and the radical, or the element. In case they are all elements that are reacting, you just write the symbol of the elements. In case it's an element and a radical, you write the symbol of the element and the radical. So in this case, we have sodium sulfate. So it is a reaction between sodium. It's a reaction between sodium and the sulfate. Now it's a reaction between sodium and the sulfate. So you're saying step 1, write the symbol of the element and the radical. Now the element here is sodium, is Na. The correct symbol, in fact we are writing the correct symbol, not just the symbol. Write the correct symbols. It has to be correct, not just symbols, but correct symbol of the elements and the radical. Now we have here sodium and the sulfate. Then now step 2, write the valencies of the element and radical above and to the right of each. Now we are writing them, we are writing the valence as superscript and to the right side of the right side of each. Now here you have sodium. Now our superscript is 1, meaning that the valency of sodium is 1. Now the valence of sulfate, as we discussed earlier before, it is 2. The valency of sulfate is 2. Now we have the valency of the element and the radical on the right side, above on the right side. Now let's look at step 3. Step 3, exchange the valency by writing them below the symbol. by writing them below the symbol. Now, the values that we are having on top, we go further by writing them. We go further to write them now as a subscript. Before we wrote them as superscript. Now, but now in this case, now we want to write them as subscript. But now we exchange them. We exchange the valency that was for the sodium comes on the sulfate. The one on the sulfate becomes on the sodium. So that we have this. 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 So this is what we have. This is what we have. Now we say that we are exchanging the valencies by writing them below the symbol. Below the symbol. Because here, the sodium had 1. Now the 1 that sodium had goes to the sulfate. Goes to the sulfate. Now here, the entire sulfate is 1. So we don't just indicate that one. We don't indicate that one. But now here sodium we indicate 2. Sodium we indicate 2. Now already we have exchanged the valencies, and now we are writing them as subscript other than the superscript that we had before. Then step 4, write the symbol close together. Write the symbol close together. Now after writing them, remember we've written them having spacing between them, but now in this case we are writing them together. Now we have we are writing the symbol close together. Now this becomes our chemical formula for sodium sulfate. Becomes the chemical formula for sodium sulfate. Becomes the chemical formula for sodium sulfate. Now let's look at lithium oxide. Let's look at our first example to be lithium oxide. Let's look at a number of examples beginning with lithium oxide. Just following the steps, then we can see. So here you have lithium oxide. Remember, you said the first step, we are writing the correct symbol of the elements or the radicals. Now lithium, remember lithium oxide is a reaction between lithium and oxygen. Now lithium, now here you have lithium, then oxygen. Valency for lithium is 1, oxygen is 2. Now the formula is lithium with the valence 1, oxygen with valence 2. Now they are reacting to form lithium oxide. So remember, at this stage, we are exchanging. We are exchanging. After the exchanging, we write them together. After the exchanging, we write them together. After exchanging, we write them together. Now you have another example of sodium chloride. Sodium chloride. Sodium chloride. Sodium chloride. Now you can pause the video and try to see if you can write the chemical formula of sodium chloride. Chemical formula of sodium chloride. So you say that we begin with the symbol, then the valency, then the exchanging of the valency, and then the formula. And then the formula. So here you have sodium chloride. So symbol, valency, then we come finally to write the formula of the sodium chloride. Another example, you have calcium chloride. Calcium chloride. Calcium chloride. Remember, you can pause the video and try out if you can write the formula in the correct way. Then you can come back and gauge yourself to see how you are doing. That's calcium chloride. Remember, we said we begin with writing the correct chemical symbol, the correct symbol. Then we write the formula, the valencies, and then finally the formula, the valencies, and then finally formula. We have another example is ammonium sulfate. Ammonium sulfate. Remember that in this case, ammonium sulfate. Remember in this case we are dealing with they are all radicals. They are all radicals. You have ammonium sulfate, the symbol for ammonia. Then for the one for the sulfate, the ammonia has valence 1, sulfate has valence 2. Then now we go ahead to write the formula. Now, because these are radicals, for the case of radicals, say the radicals, they are group of atoms which cannot exist as one. Now, because of the radical, when we are exchanging the valency for the radicals, when it is more than one, say that 2, 3, 4, 5. Now we take the entire radical, we write the entire radical into a bracket, then we write the valency as a subscript after the symbol of the radical. Take note of that. Take note of that, please. Take note of that. Then another example here, we have magnesium hydroxide. You have magnesium hydroxide. That's our last example. Magnesium hydroxide. Have magnesium as the element, hydroxide as a radical. Magnesium with a valence of 2. The oxide radical with a valency of 1. Remember, you say that for the case of the radical, when the valency is 2 and above, we write the entire valency in a bracket, then we indicate the valency as a subscript. So what we have to note that we write brackets. We write brackets for example D and E because the radical consists of 2 different elements. For example, you have the hydroxide contains oxygen atom and hydrogen atom. You have the ammonium radical that consists of nitrogen and hydrogen atoms. Now, but it is wrong to put brackets for now for the other examples. For example, for the example C, that is calcium chloride, as C and L do not represent different elements. Because chlorine is just Cl, it is one, it is an element. It's an element. So there is no need of putting the chlorine in bracket, then indicate 2. But for the case of the radical, we have to do it. We have to do it. We have to do it. So we are saying we are saying that we have to note that. So we write brackets for example D and E because the radical consists of 2 different elements. So for example, hydroxide contains oxygen and hydrogen atoms. Oxygen and hydrogen atoms. Ammonium consists of nitrogen and hydrogen atoms. But it is wrong to put brackets, for example, in example C, that is calcium chloride, as C and L do not represent different elements. Do not represent different elements. Remember, in radicals, we have elements. We have different elements that now are combining. Then another example is F. Right now, this question, we can try out this question. Write the formula of lead-4 oxide. Write the formula of lead-4 oxide. Write the formula of lead-4 oxide. Remember, you can pause the video so that you can try out and then return to see if you've done the correct thing. And then play to see if you have done the right thing. So write the formula of lead-4 oxide. So we said we first write the symbol, correct symbol. You have for the lead is Pb, you have for oxygen it's O. Valency for the lead is 4. Remember, just from the name lead-4, now lead has a valence of 4. And then oxygen has a valency of 2. So before we bring the valency down, we must divide the valency by the common factor 2. So in case must bring the valency down, we must divide the valencies by the common factor 2. So when we have the valencies between 2 elements, or between an element and a radical, or between 2 radicals, if the valency have a common factor, we divide that common factor for both the valencies, so that we can come up with the simplest one. Now in this case, you have 2 as a common factor, so you divide 4 by 2, 2 divided by 2, so that we have the lead having a valence of 2 and oxygen having a valence of 1. It's not that those are their valence, but now we are factoring out. We are just dividing so that we can have the smallest one, the smallest number possible. The smallest number possible. So let's look at another example. Write the formula of iron 3 oxide. Write the formula of iron 3 oxide. So here the valencies have no common number which can divide them and give us a whole number. Therefore, we just exchange the valency as shown. In case the valencies have no common number which can divide them, never divide using any number so that we have fraction. No, that is wrong. We just do it where the valencies have a common number between them. Where the valency have a common number between them. So like we have here, we have this example with us. We have this example here. Write the formula of iron 3 oxide. You are saying that here the valencies have no common number which can divide them and give us a whole number. Therefore, we just exchange the valency as shown. So that's the formula we have for iron is Fe, for oxygen is O. So now the formula is F2O3, because we say that it is iron 3. The question was iron 3 oxide. So that's how we write chemical formula. One, we have first to know the correct chemical symbol, then the valency for each either element or radical given. Then we go ahead to exchange the valency that were earlier before the superscript. Now after exchanging them, we write them as subscript. Then now we bring this together. Now the chemical formula is just one. We don't space it. We don't space it. We don't space the chemical formula. No space in between. Let's go further and look at writing simple balanced chemical equation. Chemical equations. So we say that chemical equations are short, clear, and accurate description of chemical reaction. They are accurate description of chemical reaction. A reaction process can be explained using an equation. Now, a chemical reaction can be explained using an equation. A chemical reaction can be explained using a reaction process can be explained using an equation. For example, when oxygen reacts with magnesium ribbon, a white solid of magnesium oxide is formed. We have been using word equation to describe such a reaction. Remember, earlier on, I have just been writing the word equation to describe such reaction. So that is magnesium. We are reacting it with oxygen to form magnesium oxide. Now, while writing that equation, the positive sign or the addition sign here is not used to mean addition, but in chemistry it is used to mean reacts with. And the arrow sign is used to indicate the formation of a product, where we write the product after the arrow sign. Using equal sign instead of arrow sign is wrong. Names of starting substances like magnesium and oxygen, like in the example that we are giving, that are written on the left side of the arrow, those substances we are calling them reactants. Remember, they are reacting, so they are reactants. Now the new substance produced by the chemical reaction, we are calling them products, as they are written on the right side of the arrow. So we are saying that the chemical equations are short, clear, and accurate descriptions of chemical reaction. So we are saying that a reaction process can be explained using an equation. For example, when oxygen reacts with magnesium ribbon, a white solid of magnesium oxide is formed. So we have been using a word equation to describe such a reaction. Thus, so this the word equation. We have magnesium reacting with oxygen to form magnesium oxide. Now we are saying that the addition sign or the positive sign here is not used to mean addition, but now in chemistry it is used to mean reacts with. In other subject you can use it as an addition, and the arrow sign is used to indicate the formation of a product. The arrow is used to show the formation of a product. Now using equal sign instead of an arrow is wrong. It's wrong. So names of starting substances or starting materials like magnesium and oxygen in the above example are written on the left side of the arrow. Now these substances, we are calling them reactants. Now what we are writing before the arrow, we are calling them reactants because they are reacting. The new substances produced by the chemical reaction, we are calling them products. After the reaction, we are forming a new product, and we are forming products, and they are written on the right side of the arrow. We are writing